Hi, I'm Leanpub from Leanpub, and in this episode of the Leanpub Podcast, I'll be interviewing Sal Kimmich. Based in the UK, Sal is a privacy and security subject matter expert and open source developer and mentor. They've led security by design across cloud, HPC, and AI, embedding ISO 27001 practices, I know I said that wrong, OpenSSF methods, and confidential computing into real projects. Their work spans developer advocacy at Sonatype, technical direction at Gadfly AI, and a privacy advisory role with Our Worlds. You can follow them on LinkedIn at Sal Kimmich and check out their website at salkimmich.com. Sal is the author of the book Code, Chips, and Control, The Security Posture of Digital Isolation. In the book, Sal teaches cybersecurity through the lens of the top 100 hacks since 1985. This is the cybersecurity book to understand the modern moment of digital defense and the hacks that made it happen. The book considers how security threat models work at every level and what attacks enjoyed exploiting the gaps in their threat models over time. In this interview, we're going to talk about Sal's background and career and professional interests, their book, and at the end, a little bit about writing a book. So thank you very much, Sal, for being on the Leanpub podcast.
Yeah, absolutely. Glad to be here.
I always like to start these interviews by asking people for their origin story. So I was wondering if you could talk a little bit about your background and how you found your way into a career in cybersecurity and with a special interest in open source.
Yeah. So I think it's an interesting story because I think for a lot of people it involves a computer science degree and moving from there. That was not the path that I took. Originally, when I went to school, what I was really enjoying and started researching was actually cockpit design for big aircrafts. Boeing 737s is what I did my research on originally. And that was really, really intensive brain-computer interface work, um, where we're building a difficult system for people to use in difficult conditions. And, I loved that, but then I found it was really hard to get a full ride scholarship, and I needed one. So I shifted my attention immediately over to medical sciences and, really creatively pursued computer science through, computation and, medical imaging. But I ended up being really good at that. So this was a lot of Python, a lot of consuming, like, NeuroDebian, because this is large brain computing. Um, so that I really enjoyed, and I learned about a thing called Brain Hack during my PhD, which is where all of the brain nerds from all around the world get together for 1 week online, and they share their code, which was my experience really of, open source. And I thought all of the experts were so interesting that I pulled them all together and I ran a massive online course for free that was all open source. It took you from finding a data set to running it on AWS. Um, and I tried to teach almost 800 people reproducible neuroscience and the principles of open science. And real quickly, we ran into a problem because we were running on AWS instead of the supercomputers I usually got to play with. And we weren't getting the same results for the same reproducible pipelines, and that's where I learned things about, you can have threading errors and hypervisors and just sort of realizing all across my career as I kept moving that there's little cracks in the systems, and you only see them or understand them when you're testing them intensively. Um, and after I stepped out of my PhD space, I moved to go work for the Missile Defense Agency and then the US Air Force. Um, and that's where I learned to have a defensive mindset about software consumption. When I moved out of that, I thought to myself, I think it's a good time for me to jump upstream, as you would call it in open source, in towards the secure kernel and towards the Kubernetes ecosystem. And I jumped in and I put in a couple of security interventions that I thought would make a lot of sense. Big bug bashes for the major cloud native system, um, and fixing up some security cracks that I had seen, particularly as I was coming through as a federal consumer. And then my consultancy has really grown from there. But I think uniquely, I think this is really why I wrote this book. I have a good amount of corporate experience in software development that is part of a culture of software development. But if you were to ask me what percentage of The Linux kernel, for example, is directly consumed by the US Department of Defense. It's probably 32 to 35%. The world works differently if you look under the hood and ask yourself, why do some parts of the internet work the way that they do? Um, and really, as I was growing up, I come from a world that's a little bit different. I come from a tribal nation, a sovereign recognized nation. And I've been really inspired through my own career working with and alongside security experts for tribal nations because they're the only security condition where I have networking or cybersecurity concerns that are about the same size as a mid to large size corporation.
Uh,
And I have all of the concerns of a US federally recognized sovereign nation that includes the federal concerns of CISA, right? It is the most interesting threat model. Um, and I think I've had enough conversations in that space with really smart people that I wanted to turn around and say, okay, we think differently about this. We think about security as an isolation concept. We always have security and sovereignty to me. One is just the shadow of the other. Um, so I dove in and I asked the question, if you're an individual or a small group of people or a large group of people, what are the types of resources that you would need? And how exactly would you practically go about trying to create a system that is secure and isolated? And where are you going to fall short from making those guarantees? And interestingly enough, for me, I think honestly, most of my career was in software. It took me a little bit of time to write this book because 4 of the chapters had to be hardware. That's where most of the scariest things are.
yeah, thanks very much for sharing that really great story. And we'll have lots to talk about the book relatively soon, including like that it is so true. I was reflecting on it when I was reading the book about how like so much of my views of hacking come from movies, and
Mhm.
and that's smart, either like nerdy or very cool looking people sitting at keyboards typing away doing software. And that's when we think of hacking and cybersecurity and stuff like that. But there's obviously the hardware level that's not as easily portrayed. And so in the popular imagination, that's just not there. But also in the experience of a lot of software developers, hardware is just something you often don't think about. But before we do that, before we move on to talk about your book, one of the themes of this podcast that's sort of grown up organically over time is moving around. I don't know what it is about self-published authors, but they move or they tend to move around. People who go independent and create consultancies of their own and things like that, but they tend to have moved around. Also, I moved to London in 1999 from the middle of Canada, and I see here you did your on LinkedIn. You did your PhD at UCL in
Did.
London. Um, what was that? Just a very general kind of what was that like moving to London for you?
It was really interesting. So I was actually in an incredibly unique accelerated PhD program. So it was half of my time at National Institutes of Health and half at University College London, um, which was really fascinating to see the cultural differences when you quite literally are in the same job in 2 different countries.
Right.
That's really interesting. Um, but I think it was definitely 2 things about it, like, London, I love it's got a lot of energy to it. I live in Brighton now because 'cause
Uh.
I'm more relaxed now. But when I moved there, I bought a little houseboat, one of those little narrow boats, and I went as far as you can east to as far as you can west and back every year. And yeah, I think a lot of my memories are, the PhD was beautiful, but I think the 4 different times my engine broke down in a random spot in England kinda shaped me a bit more at that time.
So you were living on the canals.
Yes, yeah.
Oh, okay. So for anyone listening or watching who doesn't know, one of the very cool things about the UK is that there's this system of canals that were built quite some time ago. Um, this actually gives it going to give me a good segue to the book. But and there's if you walk along them, with the awesome like river paths and stuff like that that are all over with hidden pubs and things like that in the countryside, you'll see these narrow little houseboats parked on the side of the canal, and that there are people living in them. And you can go up and down the lock system, and I've always just wondered what that would be like to live that way, and I imagine it must have been sort of a combination of kind of peace and drama at the same time.
It's beautiful, it's cold in the winter, but honestly, London is one of the biggest cities in the world. I tend to find, like, when you're in cities, you're not gonna know your neighbors, and if you do, you probably don't like them. But, yeah, I think, I grew up with boats my whole life. I think that's also part of, it's a self-sufficiency thing. I wanted to know and control every system that I was living in and also have a house that I can just rock up and put in front of somebody else's $3.2 million home, you know?
Yeah.
But, yeah, I enjoyed it, and it's a really different type of life out there, looking at it from the boat side up, and a secret that people don't even think about, water absorbs sound. So you can be out there in the center of the city, and you're always gonna have a nice, quiet night. I love it.
Well, as someone who lives in a place where people love leaf blowers, I wish I'd lived in a houseboat in London, because the nights can get pretty loud there. Um, so yeah, thanks very much for sharing that. So, I said there was a segue. So one of the videos I watched preparing for this, interview, as I think on your website, where you talked about how some of the designs for the canal system in the UK came from Leonardo da Vinci, um, and how in many ways, we're at the beginning of the age of computing. And so when we can still see sort of, actual Roman aqueducts and things like that, but there's also kind of conceptual insights and innovations and decisions that we live with as part of our, architecture and built environment around us all the time. And that although we often tend to think, it's strange that people still use the term virtual to refer to things that have to do with computing. I find that whole mindset really fascinating. Like, what is it about this obviously very real thing that we call fake? Um, but it's very real, and our whole world is being built around this kind of thing, and the decisions that we're making now about how to build things are going to be with us for a very long time. And so this was partly the inspiration for the book. And I was wondering, yeah, if you could talk about the story of how you came up with. I mean, you talked a little bit about it already, but like, there were a lot of interviews that you did and things like that, and it must have been kind of quite a journey. Uh, who did you interview, for example, for the book?
Yeah, so I had 2 types of interviews. So I interviewed every platform engineer that had sovereignty in their job title or was connected to it, if they would interview me.
Hmm. Hmm.
And what was interesting about that is a few years ago, they wouldn't have been so open or so connected, but at this point, most platforms are at a place where sovereignty is a quite literal button selling point, so they are much more interested in talking about it and, really disclosing, what is it when you are trying to continue to have platform services that are US, EU. The law around that is moving and changing rapidly. And it was interesting talking to engineers that are so sure about the security guarantees that they're making, but not
Mm.
quite sure who's going to buy them, right?
Right.
Because the world is still trying to figure that out. Um, but I think I think really one of the things that's kind of important to consider here is that you have a completely different threat model if you change the dimension of time. And I think we do have to start having a maturity around not just chasing large scale global incidents, but understanding that you're having large scale global incidents because we have to do civilization design, right? If the things that you're designing, particularly in the final chapters, when we're talking about space design, satellites, all the things that sit particularly close to our orbit, I'm more worried about. The design of those things, they quite literally may not ever come down to Earth. You are putting debris up into the sky right now. If you're putting debris up into the sky that you might lose control of, that's doubly a concern, right? That is something where I think that's not even a nationalistic concern. The threat model behind that doesn't match a nation. So at that stage, you have to be start to be dealing with treaties and agreements. But treaties and agreements are traditionally done by people who probably themselves did not get a computer science degree, right? So it's really, really interesting to watch. And I'll say this, I think we're going to bloom into a bunch of regulation right now because most of the regulation matches more to human concepts and ideas than it does to the technology itself. As our taxonomy improves, as we understand technology and where the boundaries of where our guarantees are improves, as it does with every cybersecurity breach or well done research, then you start to be in a place where we can have a minimum threshold for integrated systems. Um, that I think it's a different way of thinking that I'm going to see from a corporate engineer. It's entirely the type of thinking that I see from every engineer that I worked with at Missile Defense Agency, though, right? There's a different type of thinking and a different type of way to design and threat model. And when that threat model is expansive and you consider everything that could go wrong with the system, even if you're not sitting in a place where national security is a concern for you, I think that's a maturity of thinking about systems that is minimally sufficient. When you're doing threat models, it's usually considered you're gonna try to multiply the risk times the likelihood. That is not true. People forget it's risk times likelihood and then divide it by your actual budget. That's great.
Right.
Take out the things that you can't control, but know where your gaps are. And that's where the first chapter of this book ended up being after I interviewed a bunch of kernel developers. So through each chapter, I would go out and interview the developers for this. And I was going to have the chapter on kernels be the very first chapter. And every single kernel developer that I asked said, that doesn't make sense. If you're talking about security concerns, like it's not us, talk about semiconductor supply chains in the first chapter. Right?
Um,
Because that's where all of their concerns are.
yeah, and that's, I mean, one of the really fascinating things about your first chapter is that, you break things down by country, like South Korea, Japan, China, the United States, Europe, Netherlands in particular, and things like that, and how the connections are so strong, and there's so much interdependency, but the web of national and kind of regional interests that are kind of at play all the time in here are, you know, not just, I mean, there's just so many dimensions to them. One of them is the straightforwardly physical, right? Mining, water access. What happens if you lose water access? And that's not just for like people might be, read the headlines for cooling the AI center, but it might be for like you need to have a lot of water in order to purify it enough to do
Mhm.
certain manufacturing processes and things like that. Well, all of a sudden now we're in the, where water comes from. This is about as ancient a sort of sovereign kind of area of contestation as one can come up with. And as I was reading it and thinking about this, I was reminded that my dad worked for the environment department in for the province of Saskatchewan for his career, and he was one of the first people to do environmental impact assessments and stuff like that. And he said, and I'm just kind of this get this a little bit wrong because it was a long time ago that he talked to me about it, but they just couldn't get protections for forestry. They just couldn't get them. The forestry companies to just put the cartoon vision. They did not care about those people did not care about sustainability. They felt entitled to cut down whatever trees they felt like cutting down, as many as they wanted to cut down, with no view even to their own interest in the future. They thought they felt like tough guys when they made their no nonsense in their head decision to go cut those trees over there, but it was completely uninformed and ignorant. Um, and it only changed when the EU changed that this would have been pre-EU, but when European import rules changed and said, we're not going to import from your province unless you have sustainability practices in place to make sure that you're not exploiting, the resource in a way that's just going to destroy it for everybody in the future. Um, and so basically forestry rules in the province of Saskatchewan in the middle of Canada changed because of, you know, rules that the European Union countries made about what they were going to import. And so it's interesting that when you often I might return to this theme, but often when we talk about computers, to this day, we think we're talking about some otherworldly thing that's kind of maybe going to go away soon, or isn't as serious or physical as things like forestry or water, but it really is just like that.
Yeah, I think there's two parts of that that are interesting. The first one is sort of like the literal aspect of the supply chain, where you find the minerals. And there's something that I didn't put into the book that I can't stop thinking about. But about 2 years ago, I was at a tribal nations meeting, and we're having security discussions with heads of the U.S. Fed. And in that room, there's just a person in the room that like stands out to me, like doesn't look like they fit in the room. I go up and I approach them, and it turns out they're working for a major company in the US. I won't name it, but it was a surprising company. And he was there because he was negotiating with the tribal leaders about getting access to rare minerals, particularly in the Northeast, in which most of that is on tribal lands, right? So, right now, I was able to give you a picture of this incredibly complex supply chain. So, it is right now relatively easy to get your hands on a working chip in the world, no matter where you are in the world. Variations on the chips you can get depending on tariffs and restrictions, but it is extremely difficult, no matter who you are in the world, to be able to guarantee that that was not tampered at some point along the way, right? Um, Second, like sort of third to that, the most limiting resource in every single country right now is except for Taiwan, probably, is skilled expertise, right? So we're going to be in this situation until you can get the intellectual property out of the physical regions where it's being incredibly constrained too. The protections around like insider actor and trading of information in this like semiconductor supply chain is about as serious as you can get, because again, it's not something that could impact national security anymore. It is national security.
Yeah, and that actually reminds me of something. When it comes to security and what we consider security, I mean, you brought up the practicalities of here's what we need to do and here's what our budget is. I think another version of that is like people will build the security that the regulation requires of them, but they might not build the security that isn't required of them. And often the people making those decisions, making those regulatory decisions, might be a little bit behind what cybersecurity researchers like you are kind of probably jumping up and down, going, "Oh my God, over here." And I think an example that you talk about, I don't know if this is actually in the book, but is about a theft of Netflix data. Um, and people might think, "Oh, who cares? They got my username and or whatever, or they got my email address and password, and they know what I watched in the past. What does that matter?" But it turns out it matters a great deal.
No, I really that matters a lot, a lot. So this is something that I wish people can understand more, and it's kind of where so I've gone and done all of the like privacy training and certifications with a group called IAPP, which is typically where you go for your international certifications for that. And all of the privacy training I've taken, none of it covers a very serious privacy concern in security, which is the problem of unicity. This is a very serious problem. This is, I think, right now, if you're just a normal citizen who probably has data on the internet, this is probably your peak concern. Can you do anything about it as an individual? No, but organizations can. So unicity is an interesting problem where I can get two or more data sets. And if I'm an adversarial thinker, if I'm trying to join two or more data sets together and I want to identify a single person or a group of individuals that have similar or like behavior, I can not only find them, but I can predict in advance how likely I am to find them based on just this sheer size of the data sets with extremely low error. So while everyone is running around and worrying about what we're going to do with post quantum, they are not recognizing that we are building data sets right now, and data sets that are typically at a size that put us at extremely high risk for large scale identity theft. Now, this is why they go after specific types of data sets. They're typically going to go after like banking and healthcare because that gives you a lot of the information you need for an identity. But Netflix, when there is a data breach in Netflix, and this was outside of the Washington, D.C. area, that was so severe that that year, um, anywhere in the US, if you're doing publicly funded work, you have to openly disclose your data sets. They will be medically privatized, right? So they'll be anonymized. Even those, this is what I'm trying to say, even a fully to that standard anonymized data set was sensitive to unicity. So much so that we couldn't release a bunch of medical data from NIH in 2017. There's, yeah, I think that's really part of when you look at the total threat model and you actually really do think like an adversarial about your system, you're gonna think differently about what it is that you prioritize because it is potentially, yes, is it possible that you have crown jewel data? Excellent. You may have other data that's really, really a high target because of things like the general population size of your country, right? The smaller your population, the easier it is to reach unicity and identify a large group of your citizens. Can have massive effects on things like elections. Um, that one really, really terrifies me. It does not get talked about enough. I've given a few talks on this subject just to try to get people to care, but unicity, it keeps me up at night.
That's fascinating. And so I gather, I think maybe one of the things you talked about in some of the videos I watched preparing for this was how, and I don't know if this is related to the problem you just described, but a really important part of the adversary's arsenal is knowing where to focus their attention.
Mhm.
And if they have tools like the one if they have opportunities like the one you just described, they might choose, and they know that there's something vulnerable to that kind of exploitation. They'll go after it. Um, and but they're I get the thing I found the interesting thing I found about that is that like there's uh resource limitations on the adversary's side as well. And if something if it only lets them target more vulnerable or potentially valuable things, that's actually a very serious problem. Even if that particular tool doesn't get them in, as it were, just knowing where I can go to find the really valuable stuff is actually a huge advantage for them.
Yeah, I think yeah, I think one of the things that you get used to thinking about, especially if you're doing sort of national defense thinking, 100% of the time, the hacker for 25 years has not been some person in a basement. It is somewhere between a few hundred and a few thousand of probably full-time employed developers that work on teams who also do agile, but their only job is to know your system 10% better than you do, right? And they dedicate 0% of their developer hours to feature engineering. They're gonna leave that to you and wait for you to put a hole in your system, right? So their jobs look and feel very different. And there's an interesting sort of edge of security researchers when they're inculcated in a business or when they're doing it independently. And there's a part in my book that I thought was really important because there's a whole economy around vulnerabilities before you hear about a 0 day publicly. The 0 day just means, great, I have 0 days to patch it now. Great. We definitely didn't do that when we get that CVE, we've explained that to every bank that you have your systems in, every national repository that you possibly have it in. We've patched it there before you find out about it. And I'm pretty comfortable and happy with the communication design in that if we do full and immediate disclosure. But the amount of power that a single individual has, that might be the single most asymmetric power of warfare that we have seen on Earth so far. Because it is possible for, if they're good, a single individual to have an asymmetrically strong relationship to national infrastructure, for example. So something that I didn't put in the book, it's public news, but a few years ago, We got very, 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 very close to having a cybersecurity incident tamper the water processing system for all of Chicago. They were gonna get through with a Kubernetes hack,
Wow.
right? Yeah, if it's a scaling system, if it's an energy grid or a water system, it's going to run on those, right?
Hmm.
Um,
Right.
so you have to rephysicalize and realize that, yeah, is software an imaginary? It is until it's the thing that's going to make sure you can drink your tap.
There are a couple of things I wanted to, since we've got you, take advantage of talking to you about here. That for people who, just like this is like obviously okay. Now we're all scared, but like, can we try and have some understanding of what's really going on here? And so there's the national interest, there's the mining, there's the water, there's the, electricity grids and things like that. But underneath a lot of this is like a lot of like theory and math. And some of the like security theory kind of goes back kind of as far as you want to go in human history, because sending secret messages and preventing other people from, I think we've probably all heard some of the stories about like someone getting like a tattoo of a map on their head and then growing their hair back. And that's the way they brought the map from one place to another, things like that. But uh, I guess my way into asking you about this is one of the things you talk about is how like the best security is total openness. Um,
Yeah.
and can you maybe talk a little bit about how that like counterintuitive thing works?
Yeah. Well, I think this is probably the most interesting kind of story of open source. And so you've got to take us back to kind of like the 70s, early 80s, but kind of late 70s, and like KSOS. So there's the beginnings of the secure kernel. That was a Department of Defense project. And there's a couple of interviews still available from some of the developers at this time. Um, and they're all just crazy. They're crazy. They do not seem like they should have been in charge of what they were, but hey, wartime, Cold War, it is what it is. Um, but there's an interesting idea here. And if you really understand the idea of zero trust, it is a concept that I love. So, zero trust, you can explain it in all these different ways, but here's how it is. If I have zero trust in my system, that doesn't mean I'm afraid of it. It means I have simply built a system where I could take the entire instruction manual that tells you how to put it together and run it. I could throw that on the floor for an adversarial to pick up. They can build their own system that maybe I know a backdoor into getting into, but probably not. The zero proof, that should guarantee that you don't. But they won't be able to get into your system. So it's transparency of security measures and designing on prefer like at the base, knowing that the idea is to give away the instructions. That really, really different way of building security, but also security thinks differently about code and design, and the mathematics are important, right? So there are things called secure primitives, and those are our building blocks that we build up. And that for me is always really, really interesting to watch, especially around the Linux Foundation, because one of the primitives that I'm looking at right now is when we do get a post quantum solution, that's going to be just very specifically a primitive that's going to replace, for example, a sub part of confidential computing. Fascinating space.
So let me see if I can get this right. But when you talk about post quantum, this is probably something that people who sort of read the headlines will have heard about as well. But one of the ways the kind of zero trust can work is that basically like factoring prime numbers would take way more computing resources than any individual is going to have, and you need to do that in order to kind of break as to get a code. But quantum computers are going to be able to do this. Did I get that kind of right?
Yeah, so well, quantum computers, I mean, what we have to be really worried about there is, yeah, access to anything that has cryptography on it right now. Our modern cryptography struggles with that. There's a couple of different solutions that are getting put into place. You can have some alternatives to that, like optical chips are a possible solution space around here. Um, but As long as like, that is very different from having a zero trust. Um, Having zero trust, quite literally, no matter what it is that I'm building, it probably has a hardware constituent to it or a software constituent. You can break them apart. The only guarantee that I have to make in that is that if I hand it off to somebody else to build, they don't have sufficient information to hack what I have built. Now, as we're building that, and that's a mindset and something that we came up with as we were building the Linux kernel originally. And if they hadn't argued that, now this is crazy. Department of the Defense in the Cold War, where we're not even being terribly open about the things we want to be open about, they make this decision to flip and make the kernel publicly open code. Um, the history of the entire Linux Foundation, that ecosystem that builds out of it, is an incredible story that I wish people would not forget. Started with a couple of just really, 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 really crazy government contractors with a wild idea that they somehow convinced a five-star general was a good one, and I'm grateful to them for that. But it's also gonna have a completely different culture, a completely different way of being built than BSD, right? Those are different worlds because they come from different times in history.
Um, Having talked a little bit about some theory now, I'd like to you mentioned you wrote 4 chapters, I think, on hardware. So the other thing I wanted to ask since we've got you here is, so what if you could talk a little bit about what a semiconductor is and how it can be physically exploited?
Yeah, so the semiconductor, we're really just getting down to the transistor architecture of a system. I think the exploit that left me really more worried than anything when we're talking at the hardware level, it's an oldie, but it's a goodie. It's Rowhammer for sure. We also can call it bit feng shui, which I really do like. But Rowhammer, I want to go into the DRAM and I am going to send in electrical bursts, it's incredibly low level attack, and try to move memory around and try to pull things out of it. Um, Now, it's concerning from an adversarial point of view. There are some ways to protect that now, but it really just seems like all of the most sophisticated attacks that human beings have invented to against other human beings are replicated to a higher magnitude when you just throw things into space. So my biggest concern is basically Rowhammer, but caused by radiation in the sky at that point. And so some of the solutions that we've built at that hardware level now are helping us to have better redundancy systems up in the sky. And I think that's fascinating because Rowhammer, we had built a bunch of chips, and we still design chips in a way that's extremely easy to exploit if you've got electrical access to it. Um, and if you've got chips that are sitting on in a stack on a server farm, yeah, you're gonna call that a data center. But at the end of the day, if it takes me a screwdriver and just an electrical rod to access it, that can still be a concern. Um, the vetting of, like, inside actors for some data centers to me is really, really interesting, because those are often, especially in Europe, they try to nationalize them and say, "Alright, we're only gonna hire our citizens for these data centers." There's a few countries that are building large data centers right now that I was told when I was interviewing them, they said, "I don't know what they're thinking. In 10 years, we'll have all of these data centers, and we don't have enough hires in our country to be able to service them." So again, that, like, constraints and resources. So can I protect it at the chip level? Yes, maybe. If I'm short of protecting it at the chip level, do I want to protect it at the data center? Yes, maybe. If I want to do that, is that still even possible? Right? So, but I really don't think that you should like walk away from this book terrified, but I do think it's gonna leave you with a different way of considering as a consumer, particularly what kind of decisions you can make and at least knowing um what decision you did make, right? Choice is an opinion until it's informed.
you just reminded me of a pub table opinion I have, which is that around basically kind of security and intelligence hiring, which is that if it's too monocultural, if the people you're hiring are too, I'm just gonna say straight, you're gonna have people who don't have the mindset you need to think about how the other people are thinking, and you're gonna have too narrow a base of basically imagination and experience and kind of spirit to draw from, which is actually, I think, one of the, again, my pub table opinion, one of the reasons that a lot of the kind of like innovations do come from basically letting crazy people in from time to time, and hopefully judiciously.
Yeah, yeah, I think, yeah, because security is, the panic that we have when we find out that there really were unknown unknowns, right?
Mm, mhm.
And you do have to be smart when you're thinking about, I am trying to find that thing which is either very hard to find or is intentionally being hidden from me. Um, but I find that to be a really, really interesting journey. I also think part of my career as I was transitioning full time to cybersecurity, I was still doing SRE, site reliability engineering, and I enjoy that too. I think I just really enjoy it, right? I enjoyed watching airline pilots figure out how to not crash a plane. I love incident response. I love dealing with people when they're in a serious incident and seeing the psychology when they perform really, really well or when they need a little bit of coaching. Those are make and breaks not just for a company, but there's a lot of interesting things that brings. But in cybersecurity, it never stops being interesting to me because there's always intrigue to it, right? When it's SRE, at the end of the day, something went wrong with the power or the provider or the sun. It's probably one of those three things, right? It's going to be a solar flare or an energy outage. In this case, they can be much more complex. Um, and discovering and understanding sort of the ethos of different hackers and why they're motivated to go after different things, I think that also is something that I learned from this book we need to evolve our mindset around. They're not going after the same things they were going after before. They might just go after your Netflix data because it's easier to get to and has the same value.
Um, your book is based on a lot of history and including the history of hacks. So on that note, do you have a favorite like hack or hacker from the last 40 years or so?
Yeah, I think I learned, so you know the Hackers movie?
Yeah.
I love that movie. Who can't love that movie?
Mhm.
But in the Hackers movie, I always confused between the real one and the fake one, but I think in the Hackers movie, they called the computer worm, Leonardo, and I learned through writing this book that that's because it was directly inspired by a real hack that was called Da Vinci 2 years before. And I thought really a note from earlier in this book, I do wonder if there's anyone from a particular generation, particularly in the US, who was not inspired to get into cybersecurity because of the kind of movies that were going out. And it's that's not by chance. The movie War Games is partially funded propaganda, right? They were trying to inspire people to pursue this type of career.
Yeah, you're reminding me, there was some anecdote I heard about that movie. I think it was initially there was some computer manufacturer was like they didn't want their computers in that movie. It was something like that. Everyone knew it was being made, and someone wanted to make sure that their brand name didn't appear in it or something like that.
Oh, they were wrong about that. It was a good movie, would have been great for them. But, no, I think Hackers too, I enjoy that, and, I watch it once a year, and, I'm always really tickled by the quote, one of the hackers just turns and says, "Risk 5, like, it's the future, man." And it's like, that was 25 years ago, and I risk is the future for some countries, but, that fractured and changed and just, yeah. I think the generational change has also changed the way that we can see and understand history. It is literally true that if 10 years ago you surveyed developers, there was this really interesting study, and the highest indicator of whether or not you were a software developer 10 years ago was whether or not you had a parent who owned a computer.
Yeah, it's funny actually. One of the we didn't actually talk about this. I didn't ask you about your first use of a computer, but that's actually something that's come up like over 100 times on this podcast, just because of who the
Yeah.
typical Leanpub author is. And I can tell you, yeah, like anecdotally, almost everybody's like there was a computer in the house or a parent brought a computer into the house.
Yeah, and that creates a very specific single generation that is building and designing cultural principles and standards of communication. The next generation that came in, I would say, like, I was born in the 90s. I had a personal computer at my disposal before I was in high school. I, got to go to a computer, camp when I was 12. That's where I started doing Python, and if I could go back to my younger self, I really wish I still had access to that code because it was so bad. I wanted it to respond. I really liked building things that see and respond like a human would, at least a simile or a facsimile. Um, so I gave it a bunch of weird for loops and everything. I had no idea what I was doing, but you just basically would never know when it would respond back to you. There's so many ways that I could have done that in 3 lines that I just needed a little bit of time to figure out. Um, but I still enjoy, I think that's kind of something that I've seen. It was people that were building and using computers and seeing hardware and using it and seeing the evolutionary stages of it. And then there's a generation of people that were given a personal computer and they think that the computer ends at the screen. And they don't really think
Yeah.
about all of the ways that the computer really engages. And there's also this sort of like last thing that's changed here where um, if you were into computers 20 years ago, you would understand software or open source as just a tool. It's like a thing that you use, a thing that you do. And there's been this massive like jobification of the way that people think about coding, right? They code to have a job. No, I think at the end of the day, you need a skill set that allows you to solve your own problems. That's the whole reason why we have a massive world of intellectual property available to us in software. Um, And I think if you are interested enough to perhaps not unscrew your own computer, but to read a little bit about what that experience would be like, you're probably going to be a lot more comfortable experimenting and playing and having fun with computers again. Because there's nothing magic about them. But as soon as you demystify them, I think they get a lot more interesting.
Uh, there's so much more we could talk about and so many questions I'd love to ask you about, but one of the things that kind of has to come up nowadays is AI in basically every topic. And one thing when I was listening to you talk in some talks before this interview was how it's been some time already that like it's all bots talking to bots, and that, like, it used to be that, like, in the world of computers, a honey trap was, like, a kind of app that you got someone to use or something like that, and then somehow you know, get their access information or learn something about them, but like a person. But n for a long time now, the real action has been around bots setting up honey traps for other bots and stuff like that.
Yes, yeah, things have really, really changed. And this was really so the year before, like, GPT things were really commercially available, there's a book that I get every 2 years, and it's, called Cyber Deception, and it's a bunch of very intensive researchers that basically every year give you a few chapters about what are the threats and best practices for honeypots, and, I mean, honeypots just means I'm gonna architect a system that's looks like the system, but slightly more delicious for an adversarial and slightly easier for them to get. And then I want to watch their behavior. Um, that can be interesting and that can be legally also concerning. It is possible to interpret GDPR such that you're not allowed to observe a individual's behavior on your site on a honeypot because you don't. have them consent to behavior tracking. That is a legal argument that's been put out there. Is it silly? Yes. But is it legal? Possibly. But in building these honeypots, their final chapter that year um, stated that it was the first time that they could not handle the bot adversarials that were coming into their system. So now instead of having a system that goes and tries to, or a person that tries to engage with your system, honeypots were always meant to see human behavior. They're going to swarm it with a bunch of bots. So traditional honeypots don't work anymore. They're designed for human behavior and human hubris. The evolution of honeypots now, it's something that I've been watching, but it's a staggering game to try to play, right? Because you're playing a game of scaling robot armies on both sides.
It's you remind me sort of from the sort of very like high technical to the just kind of very practical, the importance of being able to observe certain kinds of behavior in order to prevent bad things from happening, and the conflict between that and privacy requirements. Like when you bring up GDPR, like for example, I could from our perspective, we run an e-commerce platform. There's books and sign in and authentication and all kinds of stuff going on with Leanpub, but like without going into detail, there's various ways bad actors try to target us. Um, and we're not big. We don't have a license with one of the big brand name kind of security companies, stuff like that. We're protected by the fact that the services we use do have that, of course. But for anyone listening, but being able to see some as basically the more if someone is attacking you, the more of their behavior that you can see, the better you can defend yourself, and then share that information with other people if you need to, like about the behavior, not that the actual information, but about the behavior that you're observing and the moves that are being made and stuff like that. And so I guess if you hear about oh, my privacy isn't fully protected because this company's still looking at this or that detail of my activity, it's like there's trade-offs in everything. And do you really want to live in a world where the bad actors can erase their history completely, like you want to be able to erase your own? And if you're responsible, the bad guys aren't going to go away because you want this kind of level of protection. But then you end up in all kinds of things that we can read about in the news every day, like the EU wants a backdoor, or the UK wants a backdoor in Apple iCloud end-to-end encryption or something like that, and it's like, oh, you could hear someone like what I just said be defending introducing that backdoor, but I absolutely wouldn't want that to happen, personally. So it's just like there's just trade-offs, and that's one of the things that makes it such a challenge.
Yeah, but I mean, it's changing all the time, and I think it's changing for the better. And our understanding or perception of privacy, that generally is culturally attuned, but most of us understand privacy on the internet to mean our data, which is a nice leveling field.
Mhm.
Um, but I think there's one space, or at least one story, that has really, really inspired me in the last few years. Now, if you were on the hacking side of things, or on sort of the vigilante side of things, there's often trying to go and look for sensitive data sets that are causing harm. Data sets around human trafficking are considered some of the most damaging data sets, such that you are not allowed to copy them if you find them. You can try to point to them, but you cannot copy them. We don't want to create a double vector of that data. That was creating an incredible asymmetrical problem between every government coordinating in the world and a globally distributed human trafficking system that had no care for the regulation that we were putting into place.
Mhm.
Now, this is where it gets interesting. Security and technology is the reason why we're solving that problem today. We've evolved confidential computing servers, which very specifically allows you, the only condition where it's really, really hard to protect data is when you have to compute with it, when bits have to flip. Confidential computing allows you to do it. Now, for human trafficking, we were never able to hold those data sets before. Now, when they're located from specific groups that are hired to find them, they go into servers that will never be unlocked again by human eyes. I can go and throw algorithms in there. I can see where the background's in. I can see faces. I can see age change. All of the information that I need from those systems, I can get. I can share that information between different cells of different nonprofits because we can share that information confidentially. It is currently the highest standard of security that we can implement, and that's because it is above and beyond current regulation.
Right.
So we would love to put this into place in several banks. One bank where I keep my money, for example, has confidential computing sitting in its R&D until the US changes regulations so that the language allows us to use confidential computing, even though it is the highest standard of security that we can have. So I really think we are just in a moment in time. Regulation and technology are going to grow up a little bit more together, and we'll be in a world where the guarantees that I wanna have about myself, my personhood, the data of my person, and whatever risks the computers I choose to have around me, as long as I know what those are, and I know that they're being mitigated over time, then I'm happy to keep turning the computer on and going onto the internet.
In the last part of these interviews, I always like to ask the guest about their writing process. Believe it or not, there are people who skip the first two parts about the author's life and what their book is about, and just jump to this part of the podcast where they learn about how did you write a book, what was your process like, and things like that. So I know you had a period of interviewing and stuff like that. What was your writing process like? Did you say like between 9 to 5 every day, I'm gonna work on my book one way or another? Did you have a room or a library that you went to?
Yeah, so I had a little bit of help and structure. So first I was supposed to write a completely different book for a publisher. They wanted me to write on space technology, and I said, "I can't. I have to write this book first before we get to that, because I think there's a lot that builds up to understanding it." Um, so I wanted more like space and flexibility, and then I had an old boss of mine who's also a technical author, start a, technical authors club called Software Inklings, and I've been going there
Mhm.
and talking to mostly O'Reilly writers about their life and experiences, and, they all pointed me to Leanpub. I was like, "This is definitely right for me." But my writing process is really, really simple. I did, a couple of months of deep research, and I wrote out a version of this book that I thought absolutely no one should read. One person did read it. Thank you, John, my editor as always. And then I came back to it and I read it afresh as if I had never seen my own writing. I printed it out. I always have to do this. I had to do this for my own PhD. I had to get away from my words until I couldn't remember writing them. Left it for 1 month. And then the final stage was this simple. I had to write 3,000 words every single day.
Okay, that's
Yeah.
a lot.
Yeah. It's if you're on a good day, it's about 2 hours.
Mhm.
So,
Mhm.
um,
Mhm.
but at that stage, you're rewriting a book that you've written. Um, so it's great. I enjoy things feeling messy and sloppy and creative, and then a period of completely shutting it down. I do nothing on the book for at least 28 days. Neuroscientist in me knows that it's going to take 28 days to set down those thoughts. And then I'm able to come back, and the writing that I do, or at least did for this book, um, I think it changed in the fact that, like, I wasn't even quite as scared of it anymore, because there was the stage of the interviews and having people give me what were some of the scariest and terrifying moments of their careers, whether it was a moment in policy or it was a moment in a security incidents response. And I got to sit back and say, "Okay, what if we never wanted to experience that again?" And so the final chapter of every book in this, is just a set of reminders of how do I handle this problem set well. And for me, that was really part of my writing process. If I couldn't finish a chapter of my book, giving you a clear idea of an action that you could take, then I thought, well, that's just probably not something you need to read if you're a software developer. I'm going to end with something of values that I myself can remember it. But yeah, I enjoyed that process, and the one thing I think I will always do is my 3,000 words a day, because that final book, you'll write that final full book in about 1 month at that stage, but it does mean you can have nothing else in your life. That is true.
That's true. Yeah. That just one thing I would say is that there's sort of like having done a doctorate myself. There's kind of there's sort of like the canonical two approaches. I'm going to dedicate this much time in the day to what I'm doing, and I'm going to like achieve this determinate outcome.
Mm.
And I'm definitely a determinate outcome person. If it takes 2 hours, if it takes 20, whatever it takes, you hit that outcome, whether it's reading a certain number of pages or writing a certain number of words. I saw so many people, kind of fall into what I call the defill hole, where they're like, it's that, it's kind of like, I'm going to go to the library at 9 a.m., but really that means 9:15. And then that means surfing the web for 45 minutes. And then it means, oh, I forgot to get this book, so I better go get that. And then that means now it's time to meet for your morning coffee with your friend. And, by the time 5 o'clock comes around, what have you actually accomplished? Well, you feel like you've been at work all day. Now there are people for whom that model works absolutely perfectly. And you need to, the important thing is to find out which kind you are. Um, One of the really great things about your book is the cover. And I just wanted to ask you if you could talk about that for a couple of minutes about the sort of what that cover is and where it comes from.
Yeah, so this is a piece of art from Marilu Schultz, who I hope to meet someday, but I've had many good emails with. And she does Dine or Navajo weaves, but she does highly technical weaves. So in the early 90s, Intel commissioned her to do a replica of the earliest Pentium processor, completely out of weave. It took her a couple of years. I think that it's very beautiful, but, I think it's striking and lovely, but on the book image, I'm showing you the front and the back of this weave, because on the front side, it looks like something that you might consider more like a traditional Dine weave. It's, like, brown and reds, and on the other side of it, unfortunately for Marilu, uh, it has all of the correct coloring for the dye of the dye on the Pentium chip. It is a one-for-one rendering. When it's a replica of a chip, it's one of the most accurate renderings of that has been done by hand. And in the, like, museum of art that it's in to this day, it is still facing the wrong way.
Oh my
So
goodness.
according to the artist, it's still backwards, which is wild because if you were
That's
to try that,
fascinating.
it really, really does look just like the Pentium chip. And even her, the reason she was inspired by that is because the early chip foundries in the US were filled with Navajo women. And like as far as you keep going back in this, when I always ask myself, like, is there ever a point where at least tribal nations weren't involved? No, they were here from the beginning of chip production. So you dive down in that story and it's beautiful. And so all of the fundings from us that I get, it's all gonna go directly to ACES, which is the American Indian Science and Engineering Society. And we're putting together cybersecurity scholarships through this. So if that sounds interesting to you, that sounds great to me.
Yeah, well, that's fantastic. Yeah, thank you for bringing that up. That was actually in my notes to ask me at the end, and I would almost forgot to do it. The last question I always like to ask if the guest is a Leanpub author is a kind of fun one, which is if there was any magical feature we could build for you on our platform, or if there was anything that had you shaking your fist, going, "Damn you, Leanpub! Why does this part of your platform suck so much? Can you please fix it?" Can you think of anything you would ask us to fix for you besides the footnotes, which are fixed now?
Um, I think one of the things I really liked about Leanpub was just literally the writing interface. I found I could not write anywhere else because I needed the distraction free. And I think if I had the ability to toggle on and off spelling
Right. I
corrections,
see. Yeah. Okay. Got it. Yeah. That's
because
funny.
I can get really, really into a flow, and
Yeah. Okay.
that's not a grammar or spelling flow.
That's a really good thing to.
But I just want to be able to turn it off.
Yeah.
Yeah.
No, I will note that to the team. Uh, Well, Sal, the book is Code Tips and Control, The Security Posture of Digital Isolation. Thank you very much for taking some time out of what I know is later in the evening in Brighton to talk to me and to talk to all of us. And thank you very much for using Leanpub as the platform to publish this really great and important book.
Yeah, thank you so much.